What's going on, everybody? Welcome back to my YouTube channel. We have a question here which says solve for real values of x for which 4 to the x plus 6 to the x is equal to 9 to the x. Our first step will be for us to divide through by 4 to the x. So this becomes 4 to the x divided by 4 to the x plus 6 to the x divided by 4 to the x is equal to 9 to the x divided by 4 to the x. So 4 to the x divided by 4 to the x is 1. So this is 1 plus. Now you notice that the exponent in the numerator and the exponent in the denominator are the same. So we have to group them. So this becomes 6 over 4 to the x equal to, the same thing happens here, we group them. This is 9 over 4 to the x. Why am I grouping? Because the exponents are the same. Now our next step will be for us to reduce the fraction. So this is 1 plus, now 6 divided by 2, I'm going to be having 3 all over 4 divided by 2, I'm going to be having 2 to the x equal to, now notice that 9 and 4 are perfect squares. It means 9 can be written as 3 squared all over 4 can be written as 2 squared. That's it, to the x. Now notice what I have inside of this parenthesis. You notice that the exponent in the numerator and the exponent in the denominator are the same. So we have to group them as well. So I have 1 plus 3 over 2 to the x equal to, grouping, we have 3 over 2 to the power of 2. And recall that we have an exponent of x here. So we have to raise this to power x. I'm going to be applying the law of indices here, which says that even when I have a power inside and a power outside, I can be able to switch their position. I can be able to move these 2 out and bring in the x. Why? Because when I have a to the n raised to power m, this is the same as a, now multiply the power, n times m, which will give a to the power of nm. The same thing when I switch the position, let's say I switch m inside and bring out the n, I'm going to be having, remember from the law of indices, the powers multiply. So we have a, now multiply the power, m times n. I'm still going to be having m times n is what? Nm, which is the same thing. So let's go ahead and switch the position. Why am I switching the position? It's because I want this expression here to resemble this expression. Let's go ahead and do that. So we have 1 plus, this is 3 over 2 to the x equal to, now switching the position, I have 3 over 2 to the x, and now I'm going to be bringing out the 2 outside. You see that? Very good. Now notice I have 3 over 2 to the x appearing more than once. So I can say let's 3 over 2 to the x be equal to m. So it goes to show that whenever I see 3 over 2 to the x, I'm going to be putting m there. Let's go ahead and do that. So we have 1 plus, now in place of 3 over 2 to the x, I'm going to be putting m. So this becomes m equal to, this is m to the power of 2. So you notice that we have a quadratic equation. But let's arrange this quadratic equation by moving everything on the left hand side to the right hand side. So we have 0, if I'm moving everything to the right, to be equal to m squared. When m crosses to the right, it becomes minus m. And when 1 crosses to the right, it becomes minus 1. This can also be written as m squared minus m minus 1 equal to 0. So they are the same thing. I just flip their positions. Now, we're going to be applying the general formula to solve this quadratic equation. So the coefficient of m squared is 1, so that will be our a, so that is 1. Our b is the coefficient of m, and it is negative 1. And our c is the constant term, which is negative 1. So the general formula is m equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. So let's substitute. We have m to be equal to minus b, and what is our b? B is negative 1, so I'm going to be putting negative 1 there, plus or minus the square root of b squared. Remember, b is negative 1, that's negative 1 squared, minus 4 times a. What is a? A is 1 times c. C is negative 1. Now divide by 2a, which is 2 times a is 1. Very good. So this becomes m equal to minus times minus gives you plus. So this is going to be 1 plus or minus the square root of negative 1 squared gives 1, right? Very good. So minus times minus is plus. So 4 times 1 is 4, all over 2 times 1, that's 2. So m will be equal to 1 plus or minus the square root of, now 1 plus 1 is 5, divide by 2. Now there is something we need to know about m. Let's take our mind back to this place. You notice that we said let 3 over 2 to the x be equal to m. But 3 over 2 to the x is always greater than 0, which means m is always positive. So we're going to be choosing the positive side of m. So this goes to show that m is equal to 1 plus the square root of 5 over 2. And this is the golden ratio. Now let's go ahead and look for the value of x. Let's recall that we said let 3 over 2 to the x be equal to m, right? That is what we said. Now I need to make x the subject in order to get our final answer. And in order for me to do that, I'm going to be taking the natural log of both sides. So ln of 3 over 2 to the x is equal to ln of m. Now from the law of logarithm, for example, maybe I have ln of a to the power of b. This can be written as b, which is the power, times ln of a. So let's express this like this. So that means the power x times ln of 3 over 2 will be equal to ln of m. Now, in order for me to get x, I need to divide both sides by ln of 3 over 2. So divide by ln of 3 over 2. I'll also divide the right hand side by ln of 3 over 2. Now, this can cancel this, leaving behind x to be equal to ln of m all over ln of 3 over 2. Now, to get our final answer, we're going to be substituting the value of m here. So x will be equal to ln of, remember m is the golden ratio, which is 1 plus the square root of 5 over 2, that's m, all over ln of 3 over 2. And this is our final answer. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.